So Monorepo and Micro-Frontends, why these two things enter our company? I'm going to talk to, well, I'm not going to talk about company because Paul did a great job introducing who we are and what we're doing this. I'm going to quickly go through the technology stack, explain to you what is the main product that we are building, let you know about some pain and good part of our team and code transformations, which I believe it's always interesting to know when a company actually went through some pain and understanding that most of the things that you read on blog posts actually don't really work as the people that wrote the blog post try to persuade you that they do. Then I will explain a little bit how we have what is the layout of our Monorepo, and show you the micro-frontends, for which I have a demo as well, and get to some conclusion and takeaways. Next, please. So Paul has done a very good job describing this. The only thing to add maybe is we are 30 engineers more or less in London and 10 engineers in Kyiv, and we are rapidly expanding. At the same time, we also have a Cedar UX UI designers and the same number of product owners. And the technical, apart from the maritime space, how tech enters this is trying to get the best out of web technologies and cloud computing technology to solve this problem for office space, let's say, and for a ship which float around the world in the oceans. Next. So this is a brief explanation of what our technology is. Obviously, we use React as a main foundation block for our front end, and that is, as Georgian already gave you a little touch, React is literally everywhere on our front end. The same way that GraphQL is everywhere, so we have all the communication between a client and server that happens via GraphQL. And on that topic, we will have the third presentation that goes a little bit on details in that and show you what we have achieved. Yarn workspaces is the technology that lets the Monorepo on JavaScript works so well for us. The rest of the architecture are a little bit more oriented onto the backend, but for simplicity, we use Golang on the backend. We have an event system architecture with Kafka as a single source of truth. We use Docker and Kubernetes to run the whole infrastructure and have a nice orchestrations between deployments. And in the same way that GraphQL is our main communication network protocol between a client and server, gRPC is our preferred communication on the server. The main applications that we developed is called OpenOcean Studio, and is a resource planning software for the maritime space. It is online, so it doesn't need to install, so it's not something that require any installation or anything specific, so it works on a single domain, and this is important for what I'm going to show you later. At the moment, we are forecasting of building 40 apps. This number changes towards the high end every day, but so far we're forecasting 40 apps. And we also believe we're going to build more or less 200 UI components. The current status is we haven't finished this yet. We're barely at the beginning, and we have 7 apps built. And one thing that has to be said is that what you will see in this presentation is actually just the beginning. And these 6 apps, we have none onto the new Monorepo with Micro-Frontends. Although we have very good indications that we are going to go there very soon. So we are rebuilding the web platform, and also we are rebuilding our UI components library, which I have a slide later to talk to you about it. This is a very good summary of what our product looks like, and this is a design from Sketch, so this hasn't been built yet. But on the context of this talk, what you can appreciate is how this website is sliced. So, for example, you will see the navigation on the left, the header on the very top, the notification on the right. So that is something I'm not going to talk about today. And the center part, which is the white background, is the app, basically, the content. And you will see why this division is important in a moment. This is an example of what the software provides to high-level business people. So some indications, some graphs, and some metrics for how the fleet and how the business is performing. This is another example of another interesting bit. So what I mentioned before, we have an office part and a vessel part. Actually, when I meant vessel part, they are really servers floating on the oceans. So we have some. We have one of our teams is focused on setting up all the hardware or the sensor that eventually reconcile the events from the vessels into our Kafka in the cluster. And this screen is a representation of that. So you have all your fleet in one screen. And well, the interaction that we can see now will be on mouse over. There will be few extra information on the vessels that are built by another team, which keep in mind, so this will become important later on. This is another slide, so is a little bit different, but it's the same as before. This is a vessel performance screen, so there's some weather forecast as well, and there's some engine performance metrics. So when we wanted to understand how we can build all this, because we had one meeting and designers show us this is the project, and engineers were a little bit not sure what to do next. So we sit down and we try to sketch out what we wanted as requirements, and the business came out with something very, very precise, and also developers reevaluate that and got some very precise requirements. From a business, the main part was that this application must be able to be used by different departments, but at the same time, it needs to be perceived as one single unit. So that is very important for the business. So the business didn't want to have any double product or change between domain or harder transition between one application and the other. So they really want to glue all these applications together. When I say application, is because if you think about traditional maritime company, they are typically very big, even a small one are huge, and are divided in departments. So these departments usually source the software to do their job from different parties, and this is something that actually we want to eliminate. So having multiple apps in one is very important for us. The other thing which comes from these little details is, at the same time, we want to fail and degrade smoothly. So we don't want the footer app put together some Babel translation error and crash the whole website. So that's something that we didn't want. So and the business side was very aware of that. The other thing is the commercial model. So we want to be able to have an access level control. So every login is bounded to specific apps. So we didn't want to renounce this feature just because we have one website. And lastly, but very important, as all the world is going very, very rapidly to 100% functions mobile, we wanted to be able to say app by app how much time we want to invest in mobile development. And as Georgian explained before, we want to do that with React Native. And one requirement was that let's try to be clever and put together a strategy that works in the future. So let's not get stuck with a product that we need to write 100% because we want to put in an iPad or because we want to put on an Android phone. Development had other requirements. Just to name few. Again, well, it's very similar to failing isolation, and you will see later why. but we wanted to develop and deploy completely independent. So we wanted each team to go for their own deployment process. We didn't want train deployment, which is what Facebook and other companies do. So every Tuesday you cut a release and that goes live. We absolutely didn't want to do that. The other thing, we wanted to maximize the code base. So we didn't really want to rewrite a single business process multiple times, because in those are actually, think about JavaScript, those business processes, those are where all the state machine lives, and that is where the majority of code hides, the majority of bugs hide. And then we had some interesting points from the designers, which before we were doing this transition, they had a very good feedback, which is also a complaint for the implementation of the front end that wasn't exactly accurate. So there were gaps between what has been designed and what has been put into the testing platform. So this was something that we wanted. At the same time, we wanted to eradicate, but also at the same time, we want to conform to a look and feel, which is, for branding purposes, is one website. So what is our solution? So we took many meetings, not only with developer stakeholder, which is our investors, and our business unit. And we came out with basically we need three types of changes. One change was how we organize ourselves as a company. The second change is how we write code as JavaScript developers, and how we make sure that the house that we found for this code makes sense to everybody. And everybody means a small team that can be right now, but can also make sense if we scale to, let's say, 100 engineers. What happened with that? And the third part is we wanted to change the way that we deploy our code into production. So we weren't particularly happy, and I will take you through the details of that. Organization. We had a lot of interest and discussion about this. Eventually, the parallel between Spotify and us was resulted very strong, although obviously Spotify doesn't do what we do. We're an enterprise-based software. Spotify is completely different from enterprise-based software. But what they came out with, which most probably is well known to a lot of you, I mean, just show of hands who heard about Spotify model. Okay, so let's go through the Spotify model. So I think what Spotify came out with is we wanted team to work as startup, even though we have a huge organization, even though they have in New York and Stockholm. So they didn't really want to renounce what a startup gives you. So they didn't want to give up the speed. They didn't want to have a large team. So they still wanted the operativity of small units. But at the same time, they knew that to beat the competition, they needed to release features incredibly fast and be able to give authority to one team to cut corners, to do some experimentation, to do some A/B tests. And basically, we saw ourselves not so much into the cutting corners bit, but we saw ourselves as we as well wanted to be parallel. We as well wanted to empower each individual team to talk to the operation of the maritime company that we wanted to provide software for, and understand the better tool and the better technology. So what we end up having is 7 teams, which if you see this picture, you can imagine represent the vertical columns. So each forget a little bit about the tribe. I'm not going to go into that. But if you look at the top, there is a product owner, which is the person that faces the business and has all the requirements in their head, and they are the one that has all the answers when developer needs to know something or designer needs to know something about the business. There is a business person, like I show you in the first slide. So we have UI and UX experts. So there's one per squad, and the squad is in charge of the entire product. And what I mean by that is not really a division between front engineer and back engineer, or DevOps and business as usual or anything like that. So each team is responsible 100% of delivering the feature from beginning to an end, and which means React engineering, Golang engineering, and DevOps Kubernetes specialist for us, plus designer, plus product owner, and minus QA, because we believe engineers should be responsible for their own testing. So this is what we like about the model. This is what we took on board. The question that we had is, okay, but if we make all these teams independent, how we ensure that all the React code that we have into our master is quality proof? How do we ensure that the latest things that Google is pushing on Golang are taken by the whole team, if only one team is interested in that? And Spotify again had a very good answer, which is a concept of chapter, which are these rows. So the chapter cuts horizontally the team, the squad, and basically is a collection of people of the same skills. So if you think about React, React will share all the knowledge that is proper of our company, and as Georgian said, there's a lot of this information come directly from Facebook, so you need to do a very good job to keep updated. So the chapter does these functions. The way that operates is via Slack and with the face-to-face meeting. So every now and then, the chapter can organize meeting. So each person, as a matter of fact, belongs to two groups. The squad for building a product, and the chapter to writing code that conforms to our company standards. The guild is another concept which it is interesting, but also is a secondary to the first two, and basically is a community of practice. So we have guild about cryptocurrency, we have guild about function programming, although we don't exactly do a lot of function programming, but we believe it's something good for the culture to boost, to have some space for engineers to talk about these things with the colleagues. So after making this change on the organization, this took a few months to get completed, and now I can actually say that we see the results of these changes. So these squads actually start working very well in parallel, and every part of our company that is not in a squad and does the job that is quite common, share with other squad, actually is feeling the pain that a lot of these things happen in parallel, that so myself and other people like DevOps and business parts that needs to fix a lot of things that happen in different squads, they can see the real parallelism of this. We get together and we decide what we want to share as a code, because principle sharing code is very nice, but how you do that, it's hard. There are a lot of documentation, there are a lot of tutorials online, and that's where we started, and at some point we took our own take to the problem. So first of all, as a business requirement, we wanted to share the majority of code between mobile and web, and this is not extremely simple. Georgia mentioned quickly, this was not even possible in the past, but we believe that with React, we actually can achieve some of that. So that is one thing we wanted to have. And also we have some desktop application for the vessels, which is also written in React, so we wanted to achieve this multi-platform share of the code. Yes, which brings us to the next point, not writing every application from scratch. This is ideal goal that we wanted as engineers. And also another business requirements. We wanted to be very easy for new engineers joining to write a new application with all the best practices and all the standard. So we didn't really want to force all the new apps to be written completely from scratch. And the fourth one is not something that we designed initially, but it's something that we are seeing now, because now we are into migration, and migration happen much better. It's a smooth migration if we can share this code with other repositories. So if we have a picture of the world where the code is not just for our Monorepo. What I can tell you about the results, there are a few easy wins. One is to share translations and configurations. This is something that we say since the day one, so it's easy to take away. The setup, something to make it easy for every new developer to get together. We wanted a common setup, so a common lint processing, column flow typing check, a common unit test. So this, we believe that we now achieve a stage where these are just given from the Monorepo. So a new app doesn't need to reinvent and reinstall and decide which version of Babel, which version of ESLint, and so on. So that's given. The third part was not so easy, but we get there. And I think for this as well, the next talk will show you a little bit the detail of this. Business logic and the network communication means we wanted to share all the process I mentioned before where bugs lives. For example, create a new vessels. You don't want to put yourself in a position that you create a new vessel for React, for React Native, and for Electron. You actually want to take this code away and unit test it, and if it works, there's no reason why providing different UI implementation wouldn't be a problem. So this is something that we have achieved as well. And the fourth is the most painful one, which is what everyone is talking about, which is taking the React Native 100% approach, which is taking a React Native DSL, so making that as a primary working example, and then have implementation, which is .web for the web, .web.js for the web, .android.js for Android, and so on. So there are lots of talks about that. The technology to do that, if you're interested, are React Native Web, React Native Primitives from Twitter, React XP from Microsoft. We didn't do that. The reason why we didn't is because we didn't believe that the user experience could be at the highest level possible. So we want to really be able to use all the attributes, be able to use all the properties of each component. And we followed those people online that were actually saying, don't do this because you might find problems. And we will see, I think this is one of those points that we will see the consequence in the future of our decisions. But what I can tell you is what we're going to do is we're going to share the UI components throughout all applications, which if you have one website, that's kind of given. But if you have multiple applications like we have now, it's a little bit more difficult. And this brings us to the next decisions that we had to make as a chapter React. So fair enough, we know what you're going to share, but how we're going to share it. And this brought us to a Monorepo. There are pros and cons to using Monorepo, and I'm not going to tell you that Monorepo is the silver bullet, because it's not. It has a lot of cons. So you kind of need to judge for yourself if you need to use a Monorepo or not. For JavaScript, I think there is a clear winner, which is, so if you're going to use a Monorepo, use Yarn workspaces as of today. Then in 6 months, this is completely wrong, but as of today, Yarn workspace is the tool to use. The second tool we're using is Lerna. So Lerna helps us to do a little bit of parallel testing. So if we want to launch all the tests in parallel, we can do that. And Lerna forces us, let's see if this works. Yes. So Lerna forces you to have to decide the directory that you want to share at the beginning. So we add packages, which is basically everything that we are going to share between the applications and the applications, which are our micro-frontend applications. So how many of you are working on a Monorepo JavaScript today? Okay, so it's important to understand that what Monorepo means is that these dots, this list, they are completely separate applications in one repository. So they have their own package.json, their own webpack, they have their own babel.rc, so they are completely different. And they can evolve in a different manner. So you can decide to take one and throw completely away, use Angular, that you can, because that will not affect the others. So that's the basic takeaway. The micro-frontends comes for us in this shape. So if you remember the slide I showed you initially with the design, we had the header, And then we had the navigation on the left. Well, you didn't see the footer, but I will show you in the demo the footer. And then we had the frame, which is the root. So the root contains all the global navigations that makes the micro-frontend works. And this is something that Eugene is going to talk in the next presentation. And then we had some shared components for our UI. And lastly, the images for the branding is shared, so we are sure that actually the latest image is actually what we're going to use for all the projects. And well, you can't really see this nicely, but I'll go through this with the demo with a larger font to show you the folder representation. So this brings us to micro-frontend, which is, let's say, the newest thing. We heard about this. We never used it. Nobody in our team used it, but it seems a very good concept. So imagine what this is taking the backend concept of microservices architecture and bring it to the front end. So okay, that's cool. So what does it mean? So you have the single responsibility principle. You have the front-end applications that can be changed without affecting the other code. And also you have isolation. So front application can be rewritten completely in Vue.js, and the other can stay in React. So this is the concept. And then you have a library, which there's a few. So there's Mosaic by Zalando, which is a German e-commerce website. There's one called Open Components by OpenTable, which is a San Francisco-based company for booking restaurants and also has an office in London, and a single SPA. So what this library do, they provide the frame for your micro-frontends to be delivered together and communicate to each other and make the deployment such a way that this experience of one application is actually real. We decided to go for a single SPA, which is what I'm going to show in the demo. What we found good about this is that it's very simple, doesn't have many dependencies to install, and the documentation is very well written and digestible. So yes, so if you go to the next slide, I can explain you a little bit more in details what a single SPA requires in order to work. First of all, uses System.js to load dynamically, and these are the two important words, dynamically loading module with System.js, to compose one application from different applications. Single SPA dictates that you need to have a root. Some demo call it portal, but we decided to name it root because we thought it was more appropriate. The root is basically the frame. So we have very little code in this frame, but a very important one. And single SPA as a dependency brings us the routing that glues everything together. It defines, it has an app configuration, so whenever you want to create a different app, you amend the configuration. So you have to decide the name of a new app. So obviously cannot clash, so you can have two headers. The entry point, so what is the first JavaScript file that is the single SPA is gonna invoke when it's loaded. The path, for example, we have /crewing. And the last very important thing is specifies a function. So a single SPA calls your isActive function and pass the browser location, so you can actually decide which micro-frontend you want to show in each URL possibility. So you can decide how to compose this. And lastly, you need to define a simple HTML, or in our case, a very simple React component, which has all the mount points, which I'm going to show you what that means in the demo. The application at the same level requires only one dependency, which is what we found quite beautiful about this. There's not many dependencies, you just take one. And for us is single SPA React, which give us binding to define bootstrap, mount, and unmount functionality, which is all you need to do to replace the normal React bootstrap. And then you need to tell, actually, given these mount points, you need to tell which mount point each app is going to use. And I think there's a demo now. So I'm going to, is it? Try it? Yes, so I'm going to run my demo from there because I'm gonna switch over through terminal. I'll show you how Webpack work and show you also the implementation of the website.
Maybe you can use a microphone so like people will hear you from here. Okay.
Okay. Oh, thank you. So in this screen, you see all the applications. They have their own separate Webpack build. So this is not, there is a way to launch all together, but for the sake of this demo, I wanted to show you that actually this comes from different places. And well, it's a little bit big so everyone can see. But this is basically, well, I'm going to tell you what it is. So the first one is the root application, and the other are header, navigation, footer, and example. Plus the sixth, which is a bonus I'm going to talk to you later about. Yes, so going to the code base. So I'm gonna, well, first of all, can everybody see the left? So that is, let me make it a little bit bigger. This is how our Monorepo looks like. So there is one package.json, which is the root one. And in this package.json, the only thing that needs to be specified is that is a workspace. And you specify the name of your workspaces here. And then after this, Yarn Workspaces knows where to install node modules correctly and makes everything work. Now on the left, you can see that we have this native, which is the native code that Georgian was talking about before. We have these packages, which is the shared modules. So these are modules that are shared on our private NPM, which give us a possibility for other repositories to use this code because it's just is importable. And the platforms, platforms is something coming from another branch. In this web, we have the example, which is the content of the Micro-Frontend application, the root, and the navigation, and the other. So even the header and the footer are different applications. So there's actually very, very similarity to the single responsibility concept. So I want to show you, first of all, let me make a little bit smaller. So this is the simple component that has the hooks for the Micro-Frontend application. For example, you can see the navigation here with this ID, and so on and so forth. So this is the only pages that is provided by the root. And as I was saying before, there's only one, this is the configuration file. There's only one dependency on single SPA. There is this function which is active that defines when your application must be active. And then there is this configuration which has a name as the first entry point, which is loaded with system.js, and as a path. So for example, the header, the footer, the navigation, we want them to be at the root, but the example we only want on /example. If we go to this example, which is the fullest microservice that we have at the moment, as I was saying in the slide, there's only another single dependency, which is a single SPA React, because we use React, and defines the bootstrap, the mount, and the amount for us, plus the document name, the document ID, where we want to mount all this. So there's one important thing to keep in mind about our mount. When you decide, so we mentioned the 140 apps, so, and now you just saw that there are functionality to mount this. So what happens is that when you unmount, this application exits the memory. So you lose completely the state of that application, and the amount is used for that. And this preserves the fact that if you want just to have memory allocated to what you see on the screen, you can do that. And so this is, let me see if, yeah, this is all code-wise, and this is the result. Put a little bit smaller, not so much. So let's go to the dashboard. So the localhost 9000 that you see on the URL is actually the root, the root domain that serves all the Micro-Frontend applications. And you can see if I hard refresh, what you can see is that the root is arriving immediately, and then each other application is arriving one by one. So, well, this is quite slow because it's in development mode, but once all of this is bundled, this is going to be very fast. And the other thing to notice is this is the root level, so there's nothing here. But if we go to, if you go to the web example, we have example here, and now we have this application, which is our example application, which is loading. And this is a very simple graphical server that we put together for the demo. So this is how it works in development. The other thing I wanted to show you is what happens if we have a problem, or Kubernetes has a problem to serve one of these. So let's just stop the header and see what happened here. So again, the root is the first come. But so we have a footer as well. So we have 1, 2, 3, but the fourth Micro-Frontend didn't come because we just killed it. So this is very, the same happens when we have a JavaScript error. So this is very good for our business point, which wanted complete isolation between deployments. One problem that we found, and that you can see as well on this screen, is that each application needs a different webpack, and this also means a computer is allocating a lot of resources. So we found that this is a problem for us, and we came out actually just in time for this talk. We came out with another thing, which is a standalone build, which is this one, and basically as this application that can be run as a standalone on a different port. So, and we believe that this is the best way for development mode to just develop your own application in isolation without thinking that all the frame and all the communication with the single SPA exists. So you can go on for your route and your plan, and then when it's time, you can integrate that into the Micro-Frontend apps. Good. So that was a demo, and another part that I wanted to talk about this, which close the circle with how to deliver the common branding and the share code, is the UI library. And the reason for this is for us was clear that we wanted to do that, and I believe for majority of teams is the same situation. And not to spend too much time on this, we found that our custom component implementation had a lot of bugs, and we couldn't go as fast as designer were designing. So after we actually talked to designers, we came to a conclusion that was much preferred to have speed of iteration rather than have custom designs. So we decided to concentrate on finding the best off-the-shelf UI library. We analyzed 3 of them. Material UI and Semantic UI were 2 that we evaluated, but then at the end we kind of agree all together that Undesign is what we wanted to use. Undesign is produced by I forgot who's produced for. And sorry? Yes, Alipay, right? Alibaba. Yes. It's produced by them, and sometimes it's a problem because GitHub issues are all in Chinese, but we work around with that. But we like it very much because it gives us a lot of UI components to reuse. In fact, the menu that you saw is entirely out of Undesign, so we didn't write any custom code for that. And we believe that this is the way forward to have a common branding between teams, and especially if you have an enterprise level application where consumer is not the center of the target. I believe that you should really consider to have a UI library that is already made and maintained by the community. If you can go to the next slide. The further part of our change was deployment, and I'll run very quickly through that. So we use Docker container on the front end as well. So the way that works, each of these bundle.js, the Webpack produces for our application, are delivered by separate Nginx containers, and each of these containers is shipped into production. And yeah, so and this really ensure each team that they can do their own deployment without waiting for other teams. And the most important thing is that their deployment will never be able to break any other Docker container because it doesn't touch those. Next. Okay, so some winning points, which through the presentation I hope I gave away already. We had a seamless transition across apps. So I show you one example. We had other tests within our team, and that is something that is a reality, Micro-Frontend application. And multiple application really feels like one, and we really feel like that developing different application was actually developing different applications. So all the problems that this implies. And yes, well, the groups are given because this is each bundle can come from a separate URL. So we can use the URL, and you can use a nice permission that is mapping the application for different users. The development experience it's very good with the Yarn workspaces. So the one thing that I think is the best takeaway from the Monorepo is the fact that when you amend or you change or you add the functionality in the shared packages, which is the part that was at the top, you can use those packages immediately. You don't need to publish into NPM and do all the dance to get the new components and try to get a new version and try and make sure the NPM is not down that very second. So this is very good for us. The other takeaway, as I mentioned earlier, so one thing that we found very, very fast for us to develop forward is to have a UI component library developed by a community that doesn't have bugs. And if bugs are present, there is an open source community and a big company that maintains and fixes them. And we are applying the atomic design principles into how we structure the code. And this is very important to make us share the majority of code between these applications is using this atomic design, which the design team is already using for their own practices, their own daily work. And the way they use it, as a team, they ensure they don't repeat themselves. So we decide to take this concept as engineers and just use this to not repeat ourselves. So we can pass over very quickly. This is exactly the same slide that we saw before, and I believe that we tick all the requirements that we have initially. And some pain points, which I think is very interesting to understand. So this process of researching and implementation, it was not quick. So we had this idea initially around June, and I think we're just starting now to see the benefits of what we're having. The standalone application just got merged into master today. So this is not something that we can say, well, we have a lot of experience building on. But these are the main things that I wanted to share with you. We were quite unlucky to get into the stage where Babel is passing from 6 to 7, and this didn't really help us when we wanted to use Yarn workspaces to have the different node module installed on the root or on the different application. But eventually, I don't think that is something that will happen soon in the future, because once a lot of components will move to Babel 7, you don't have breaking changes between applications. The installation of Yarn node modules was a big pain as well. So what we found out is that actually they're not all the time this installation, even if we have a Yarn lock in different machines in different environments, actually doesn't install everything in the correct order that needed to be run, and this can be linked to the first point as well. But for these, I think Facebook is coming up with a fix with this. So that has been through 2-3 weeks that the Yarn team has been talking about getting rid of node modules completely and just take your local cache to install the node modules. So that will get rid of this problem completely, because we will not have anything to install, but Yarn lock will actually be the first point of contact to understand the versions, and then there will be another map. But this is a big topic, and I'm not gonna explain very well. I'm not gonna describe it to you very well now. The third point that we're still debating, and you'll see the presentation a little bit on this, is whether we want to use Redux or not. Right now, we are most onto the not part. So we want to get rid of Redux as much as we can. And the fourth one, which you saw, is that Webpack translation takes too long. And this is a problem if you want, for any reason, to work with a lot of micro-frontends in one go, you will need to be prepared to wait a couple of minutes for this boot up of Webpack and to have subsequent build. Next, please. Takeaways, which I hope, if anything has to stick, I hope this three will. Just use microphones only if you really, really need it. It's not something easy to set up. If you're working with an organization with multiple teams, it's good for all the things that I mentioned before, but it's really a big commitment for your organization. So don't take it lightly. Don't use Micro-Frontend if you have a website with 2 developers or you don't have different. That is going to be a pain for you. The Monorepo thing is, as I said before, please be careful when you decide to do such thing. There are pros and cons on both strategies. So as before, the majority of you said that you didn't work with Monorepo. I think there are very good parts in the Monorepo, and I suggest to check what Google, Facebook, and Uber are doing. And all these companies have Monorepo, and wasn't always like that. So they explain very well on the internet what are the pros and cons. But please very carefully examine for your team what is the best solution, because I'm not going to advise a pro or against, because it's really a decision that must be taken by all team to analyze if the constraints are actually acceptable. And the third is I will advise anybody to consider at least to create your own pattern library. So if you use an external library like we use Undesign, that's great. If you don't, still, I think making a pattern library since the beginning, even if you have a small project, will will really increment your speed in development and will make it incredibly easy for the next person to join and to write code in a way that looks the same as yours. And maybe the next slide has the most important suggestion that you should really do what works for you. Don't listen to me, don't listen to talks, don't listen to blogs. Just use your own skills, just analyze, look inside your company, look inside your project, and don't just take Micro-Frontends because it's cool. Don't take React because it's cool. Just do what makes sense for you. And that, I think this is what can be taken to any technical arguments. And I think that's the end of my talk.